Problem 43, find the x-coordinate of each point on the graph of y is equal to 3x plus 10 over x, where the tangent line is parallel to the line y is equal to 20 minus 2x. The only piece of information that we need from the tangent line here as being parallel to this line is that this line has slope equal to -2. Y is equal, because here that's the coefficient of x right in here. So what that's telling us is we're looking for when is the derivative of this function, when is y prime of x equal to -2. So to do that, well, we need to compute y prime of x. So y prime of x is going to be 3. The derivative of 10 over x, that is 10 times x to the -1. So that's minus 10 times x to the -2. And so we want this to equal -2. And so 3 minus 10 times x to the -2 equals -2. We have an equation here to solve. We want to solve this equation here for x. Let's subtract 3 from both sides. -10x and -2 is equal to -5. Divide both sides by -10. 1 over x squared is equal to 1/2. So x squared is equal to 2. So x is equal to positive square root 2, or x is equal to negative square root 2. Those are the two possibilities that we have for this. Okay, so that's problem 43. The main thing here is realizing what is it, when the tangent line is parallel to this line, being able to interpret that to say, oh, we need slope to equal -2. Okay, that's problem 43. Problem 44. Particle in the fourth quadrant is moving along a path with this equation here, and we're told that when x is equal to 2, the y-coordinate is decreasing at a rate of 5 centimeters per second. That's telling us dy dt is -5. And so then we're being asked what rate is x-coordinate changing at that time. Okay, so this is a related rates problem. Let's take the derivative of everything here with respect to t, with respect to time here. So let's see here. The derivative with respect to t of x squared is 2x times dx dt, plus the derivative of xy with respect to t. We're going to use the product rule. So the derivative of x is going to be, because we're taking the derivative with respect to t, it'll be dx dt, that's the derivative of x times y, plus x times the derivative of y with respect to t, which is just dy dt, plus the derivative of 2y squared with respect to t will be 4y dy dt. The derivative of 16 here is 0. Okay, so this is what we have going on here for the equation that relates x and y and dx dt and dy dt together. Let's just factor out the dx dt and the dy dt on the left. So dx dt times 2x plus y plus dy dt times x plus 4y is equal to 0. Okay, so now let's figure out what is given here. We are told x is equal to 2. That marker's pretty dead. We're told that x is equal to 2. We are told that dy dt is -5. And we're told that we're in the fourth quadrant. So being told that we're in the fourth quadrant, we can plug in. Okay, so quadrant 4, that is x is positive, y is negative. So x squared plus xy plus 2y squared is equal to 16. X is equal to 2, let's plop that in. 2 squared is 4 plus 2y plus 2y squared is equal to 16. Divide everything here by 2 and move the 16 to the other side. We should get y squared plus y. And then 4 minus 16 is negative 12, but we divide that by 2. Negative 6 is equal to 0. And this has two solutions because this factors as y plus 3 times y minus 2 is equal to 0. So y is equal to negative 3. Y is equal to negative 3. Y is equal to plus 2. Okay, so what do we care about? Quadrant 4, we want y negative. Cross out y is 2. Choose y is negative 3. And so now realize that we have information here about dy dt. That's negative 5. We have information here about x. X is 2. We have information here about y. Y is negative 3. So dx dt times something minus something times something is equal to 0. Now we just finished solving this for dx dt. So this would be dx dt times 4 minus 3 is 1. Okay, great. Minus 5 times 2 minus 12 is negative 10 is equal to 0. Dx dt is equal to negative 50. Okay, so this relates together. This relates together x, y, dx dt, and dy dt. A nice related rates problem.